I'm Volodymyr Kosharsky. The topic of my report is optimal algorithm of... sorry. Can you see my screen? Yes?
Yes.
Yes, it's okay.
And can you see my laser pointer?
Yes, we do.
Yes. Let's start. My name is I'm Volodymyr Kosharsky. The topic of my research, my report is optimal algorithm of polarization selection power line on the background of the underlying surface. Today the problem of damage to helicopter as a result of collision with various objects, such some towers or supports, and it's maybe some power lines or some elements of power lines. This problem is very relevant. Collision with upscale mostly occur for a number of reasons. It may be lack of normal visual inspection, invisible of some objects against the ground on the underlying surface. Maybe it's low angle of the sun, and sometimes it's maybe darkness, and etc. It's based on the above. It can be stated we can use we can't ignore this task to protect our helicopter, and we need to create a method of polarization selection of power line and use this method in helicopter radar. And you can see in this image some damage of the wire and helicopter propeller damage. And today in leading countries of the world, a significant share of attention has been paid to the development and modernization of system methods and algorithms for detection of scales in the optical system for detection power line, some laser scale detection system, and radio range system. But system method, optical and infrared range have limited efficiency in difficult weather. When weather such as rain, maybe it's fog, snow, and etc. It advisability to use radio range, and as a result of the analysis of existing methods and algorithms for detection power line, it was established the most offensive is the use of polarization characteristic of radar signal reflector from interference. And we have some article, and this article tell you about how this method, some types of this method we can use. And first, we should consider the initial data and create and write the emitted signal and the emitted signal and the received signal can be responded by the following form. The problem of optimization the method of signal selection parametric radar was solved by the using method of maximum likelihood. You can see in this formula this method. And after performing intermediate calculation, a method of polarization anisotropic opposite again a polarization isotropic background was obtained in the next form. You can see this type of new method. The structure diagram which described operation according to the developing algorithm is present in figure 7. You can see this diagram, structure diagram in this image or figure. Sorry. Next, to about the effective of the development method, the well-known algorithm or polarization compression of interference was used. It's a well-known algorithm, and you can find the algorithm in most part of books or and some literature. This structural diagram describes the operation of the well-known polarization compression algorithm is shown in figure 8, you can see. And next we use these two algorithms to compare each and say that algorithm we create better than this well-known algorithm. And start we to test the obtained method of polarization selection of selection, polarization selection of object lines. Sometimes it's with we create fragment of 3-scale model of Earth surface and create model in this surface and create model with underlying object. It's some type of power line we create. The generated reflect the signal, and you can see it's in figure 9 or 8. Sorry, 8. It's the generated reflected signal included components reflected from Earth surface and the power line. You can see in figure 8. It's our power line we detected, or it's a reflector signal for and the signal to noise ratio over maximum interference at the receiver's input is 0.57. And the signal to noise ratio on the output of the known compensation is 2.71. And you can see the result of polarization selection use well-known algorithm and our algorithm, and the signal to noise ratio on the output of the known compensator is 2.71, and signal to noise ratio on the output of the developed compensation in its 30 and 45 point. From the result of simulation model, it can be concluded that triple noise compression provides the highest selection efficiency in comparison with the known algorithm of signal weight subtraction. And next, we start we do some experiment, and experiment studies were carried out using a model of polarization radar, which was developed in our university at the Department of Aerospace Radioelectronic System of the National Aerospace University. General view of this radar you can see in figure 10, and part of this radar is Cassegrain, antenna Cassegrain, antenna rotation device, and some receiver, transmission, amplifiers, and etc. This radar work in frequency 95 GHz. The field of view was more than 120 degrees. Vertical phase spin you can see in figure 11a. It's vertical object and this object approximate Vosimeter 8 meter height, located on the we can see fourth floor on the some buildings. was used as the object of the study. The distance to the object of study is 2030, 2050 meters. The presence of interference can be observed on the study road. You can see some trees in this position. Next, we can see in figure 12. Figure 12 shows that the vertical wire in a previous figure is observed only in the vertical polarization. You can see this in figure 12. It's element B, and in the vertical and horizontal reception channel, you can see our signals. It's horizontal channel and vertical channel. The signal to noise ratio at the input of the compression is 1.9 dBm. The result of polarization signal selection is shown in another figure. It's figure 13. The signal to noise ratio for the well-known algorithm is plus 14 dBm. It's 14.2 dBm. And for algorithm, optimal algorithm, it's 24.1 dBm. A well-known compression gives a gain is signal to noise ratio compressed to compressor. Yes.
Dear Volodymyr, please, your time is coming to the end.
Yes. It's 1 minute, please. The obtained result demonstrated that the obtained algorithm distance object with pronounced polarization characteristic against the background of interference and polarization intruded objects are compensated. You can see we compensated this object. And in the result, we create some new algorithm, and this algorithm increase selection polarization object than that well-known algorithm. Thank you for your attention.
Thank you, Volodymyr. And I welcome some questions.
Okay, I have a question. Okay, Volodymyr, please show any picture with result of background compression. Yes, for example, this one. So interesting that in radar technologies, for example, maximum distance of radar operation, it's taken into account rather cross section of the objects. The bigger radar cross section, the bigger distance for detection. In your situation, there is also interesting result that it must be. I didn't see it. So the question, if your result depend on the polarization characteristic of the object, and do exist such parameter like polarization characteristics of the object that you try to see or try to make visible on the background of the observation. Do you understand the question?
1 second.
So I mean that line, you can find power lines, yes? You can find some straight objects,
Yes.
but do these objects have some characteristic? And if algorithms, they depend on these characteristics.
Yes, of course. We try to find some object, and this object have some well-known characteristics or use, or you can see in horizontal or vertical object we can found, and you can see in for this. Research object. As this research object, we can see only in a vertical channel, and in horizontal channel, we don't see this type of object. And this algorithm use compare these two channels, and if in one channel we have found some object and another channel we can't found this signal, this how can I say this sorry, I just forgot word. Com, com,
Yeah,
compensation.
say it in other language.
Maybe compensation object with same maybe polarization and highlight object with one of the maybe polarization. I forgot.
Okay. We see that the difference between channels, it after give us higher characteristic. But the question was another one. You have, for example, power line. Yes, it's a metal thing, the long one, the thick one. And for example, you have some wire. Do they have the same polarization characteristic or not?
In power line have maybe some cross polarization characteristic, because power line is maybe not simple structure. It's a structure where we use a lot of wire, and they I don't know, закручені. Is this a structure? Maybe I can
Okay,
image.
I understand. Okay, the better characteristic power line has than just one.
1 second, sorry.
Okay, thank you. I don't have any question.
All right. Anyways, yeah, feel free to use translation if you need to have help. So that's absolutely fine, and that's no worries. I will also, from the practical reason, I will also suggest you indeed to have your names and surnames in English when you type. When you have the type of your name in the chat in the Google box, so it also will help the others, because not everybody is speaking other languages as most of you. So this is the kind of thing that could help. Anyways, I'm going to post in LinkedIn also the information about today's session and the conferences. Please feel free to join me. I send the meeting invitation to the LinkedIn to most of you, and to Dennis, for instance, so we can keep in touch. This is just practical information. Well, our session is going to end, and we will start with my session for in about 1 hour and 10 minutes. I'm wishing you good lunch, good afternoon, and and the link is remain the same, correct, Simen?
Yes, the link stays the same, and the time is in 1 hour.
Okay, in 1 hour. So it's just 3 hours, 3 hour your time.
No, 4 hour time and 3 p.m. your time.
Okay,
3
okay. Agreed. Okay. Thank you very much to all, and we see you soon.